In lecture 16, we'll be discussing a topic something known as scope, in which we will see that what variables are visible where, because obviously if you haven't declared a variable, later on you cannot use it. But we will see that if you have same name variables, how can you use them, even though that's not a good practice, but just to understand the visibility of where the variables are visible. Then we will do some review questions, and then we will do some practice problems. Now let's go to the scope. And scope of an variable or maybe an identifier. By identifier I mean anything which identifies an object or a variable, and the scope of an identifier it means that part of a program where it can be used. I mean, let's say for example, obviously you cannot use variables before they are declared, so that means that their visibility or their scope actually begins when those variables are declared. So let's type in an example, and I'm going to just delete these things. Okay, so now we have typed the program using these standard things which we write, include IOStream using namespace standard, increment void, and in the end return 0. So you need to type it everywhere wherever you are typing the CPP program. Okay, so coming back to this example, x equals to 11. I haven't declared the variable yet. That means x is not visible here. It's going to put up an error that since x is not declared, and what is x, because compiler doesn't know about it, that what type of x is, simply does not pick the types by automatically. You need to declare it first. So obviously x is not visible here. I mean, x simply doesn't exist here. Now if you have declared integer x, that means x is now being declared. So that means that x is now visible from this point onwards. So I mean, if I put more curly bracket, that means it's kind of a compound statement, and it actually defines the code blocks. I mean, this curly bracket goes from here to here. So that means I can collapse this. I mean, just an example. I mean, that means the whole thing, the main function has a block of code or code block going from here to here. Now you probably would understand what code block actually means. This thing is another code block. I can collapse it and expand it if I want to. I mean, this thing is performing some action. If I want to, I can have multiple curly brackets if I want to have some limited scope code blocks. Okay, so integer x equals to 11. Sorry, integer x now we have declared here. That means that integer x is now visible here. I mean, from this point onwards, and it's also visible over here as well. Let's see what we can do over here. So if I do x equals to 22, that means the value of 22 is now assigned to x. So that means it's okay here because x is visible here, or this is in the scope of x. X is actually visible here, and it's actually visible from this point onwards in this inside code block as well as here as well, because these two lines are actually within this code block. So that means that x is now visible from this point onwards to its own code block, which is, or its own these curly brackets from this point onward, as well as the inside code blocks as well. Now if I do y equals to 33, because I haven't declared y yet, that means compiler will throw up an error that which saying that y is not declared, or it's an undeclared variable. Simply y, the compiler doesn't know what y is. Next thing is, if I now declare y, that means integer y is now declared. That means that I can assign value of 55 to y. That is okay because y is visible over here. So if I write x equals to 44, this thing is going to override the value here. So when I declare the value of, when I initialize the variable x, I did not assign any value. It probably just contained some garbage value. Then I have assigned the value of 22. Then I've overwritten the value of 44. That is okay. So if I mean the value of x is now 44 over here, and if I do x equals to 66 over here, that is also okay, because I mean that will just, I'm going to put out an example, and you will see in an example in the next code. Now this thing y equals to 55 is also okay, because I have now declared variable y. Now there's the important part. Now pay attention over here, that x equals to 66 is okay because x is declared here, and it's actually visible in this inside code block, or even if I just declare another code block, x would be also, sorry, x would be if I just declare another code block over here, x would also be visible over here, so no problem about that. Now if I just delete it, if I do this y equals to 77, that means that y, I have declared y over here, y is visible from this point onwards all the way to here, this point onwards all the way to here. Now if I declare another code block or another compound statement, y would also be visible over here. So that means that whenever you are declaring a variable, the scope of that variable would be from that point onwards, and that variable would also be visible in the in any code block contained within the original big code block. So that means that y is visible from this point onwards to, I mean, any other code block. If you have, I mean, you can just write any statements of y equals to something or y equal to some expression, y would be visible here. Y is also visible over here, but y is not visible outside its code block. That means that y is not visible outside this code block. So if I can just take a pen out here, so and write on the screen. Okay, so now I have I'm going to write on the screen. Let's say I have a big code block, and I'm going to name that code block main. So anything, if I declare it within main, let's say if I declare integer x within here main, so this would be visible all the way from the starting bracket of the main function. Sorry, I mean the main function starts over here, not here. So a starting bracket of the main function all the way to end over here. This integer x would be visible in all of this code. Now if I declare another, or if I have another code block over here, this integer x would also be visible over here. Now if I have another code block, let's say I'm going to make another example over here, and I'm not going to name it anything. You can just have a main function, or I mean later on we would have some compound if statements and else statements in which we have multiple curly brackets. We might have some loops as well in which we would have some multiple curly brackets. We might have some nested and parallel scopes as well. So I'm just going to write some curly brackets over here. So if I declare a variable integer x over here, so this integer x is visible all the way from here to here, even then it's also visible from inside within this code block as well. Now if I have if I declare another curly bracket over here, so that means if I declare a variable integer y over here, so this y is only visible from this point onwards all the way to this curly bracket only, this curly bracket only. So if I have another let's pick another color. So if I declare, sorry for small writing, if I declare some or if I make some other curly bracket, this y, I mean these curly brackets are within these two curly brackets, that means this y is also visible over here. But since now I have moved out of these curly brackets, this y is no longer visible over here. So that's what we are talking about, that since we have declared, let me close this thing. Okay, now since we have declared the variable y over here, this y is visible over here as well as over here, but now we have moved out of the scope. That means y is not visible over here, because this thing, I mean all the way forward, but within the scopes as well, this y is visible, but not after that. But since we have declared integer x over here and we have written a code block, so that means that x is visible all the way down until we reach the end of this curly bracket, which goes all the way to here, because x is declared within these curly brackets. So that means that I cannot use x over here because x is not declared over here, but now I have declared variable x. I can see this variable x this point forward in all these all the curly brackets and even nested curly brackets. X is visible over here, x is visible all the way over here, as well as x is visible over here as well, because this thing is declared right after this curly bracket. So just to summarize this example, the scope of x, this x, actually extends from the point where from where it is declared to the end of the main function. A main function body is going from this curly bracket to this curly bracket. Obviously you cannot use the variable x before declaring it, so obviously there is an error, but it's visible this point onwards. The scope of y extends from the point from which is declared. There's an error here, but now we have declared y over here. I could write anything over here, and the scope of y extends from the point from which it is declared to the end of the internal block within which it is declared. So if I just remove this, so this means that y is visible from here, this point onwards, to here. Had it contained any internal core blocks as well, within curly brackets, y would also be visible over there. Okay, so a program may have several identifiers or objects with the same name, as long as their scopes are nested, or should I say not joint. Let's write another example. Okay, now we have typed the code, so let's go line by line, and I'm going to explain that what I've written over here. So I'm just demonstrating the nested and parallel scopes. So the basic structure include IOStream using namespace standard, and in the end return 0 with an integer main void that we have typed written so many times. Okay, now with the new thing which I've done is, before starting the main function goes from here to here. So let me collapse that. So the main function goes from this curly bracket to the end of that curly bracket. I have collapsed that over here. So before starting the main function, I have declared a variable x equals to 11. This x is actually 11, and this is a globally visible variable all the way in the whole program. In a whole code, this x is going to be visible, and since this x is going to be visible in here from this point onwards, here all the way over here, but I have done something new over here. So since I am discussing the nested and parallel scopes, so what I've done over here, that within the main function I've declared another variable integer x equals to 22. So that means that this x is different than this x. So the x which is initialized with the value 11 is actually a global variable. I've explained that. So its scope or this visibility extends all the way to here, even after that as well, after the main function as well, because it's defined outside these curly brackets. So it's essentially visible in all of the curly brackets code blocks whenever if you write from this point forward. So the x which is initialized with the value of 22, this x is actually visible from this point onwards obviously, but within these curly brackets. From this point onwards, to here. So that means that this x equals to 22, or this 20 value, this x, this is a new object, mind that this has the scope limited to the main function. Now since this x is nested means, I mean, something which is inside another thing. So this x is next, so this x or the scope of this x is actually nested within the scope of the first x. That means that this thing hides the globally visible x over here. So in this scope, from this point onward, this x is going to work unless you have another x over here. So I mean, even though, I mean, if I have written this thing, I haven't declared it, I've just used x equals to 22, this thing is going to overwrite this value. But since I have declared another variable, so that means that integer x equals to 22 is a new object. It's actually hiding the first x within it hides the first x. I mean, this x is actually visible in this main function. This integer x equals to 22 hides this x equals to 11, which was visible, but now this thing hides this thing. So that, I mean, this x equals to 22 is actually visible from this point onwards to all the way to here. I mean, it's actually hiding. It's not overwriting, it's hiding. I mean, this is a new object. I mean, this was an old object. It is also existing, and this is also existing over here. If I haven't overwritten any value, so that, I mean, or if I haven't declared any other variable x, so that means this x is, would have been visible from this point onwards to here. And now in another code internal block within these curly brackets has a value, I've declared another integer x equals to 33. It has a value of 33. This is its scope is actually limited from this point onward to here. That's it. I mean, after that it simply doesn't exist, because I mean, had I written another code block from here to here, I mean, this x is going to be visible over here. In the last line, where's the last line? In the last line here, I have done something known as scope resolution. So I want to go from this scope to the previous scope or the larger scope. I can use something known as a scope resolution operator. You might have remembered that if we did not use this line, we had to write standard : C out for, and standard : C in. I mean, those double colons were actually the scope resolution operator, and it is used to access the global x, or the x which was visible but it's now hidden, but to access the global x that is otherwise hidden in the main function. So let's run this code and see what happens. So this x is, if I do C out over here, x is going to be 11. Okay, now if I write integer x equals to 22 and then write integer block internal block begins. So let me write a C out over here. C out value of x is an x, and let me write some spacebar and L. So that means 22 should be visible here. Okay, and integer x equals to, let's first run this thing just to make sure it works. Here it is. X into value of x is 22, so this x is visible here and within the internal code block as well. Now I have declared another variable within this local or internal block, which is essentially a nested block within this code block, or the compound statement, whatever you call it. So integer x equals to 33, this x is going to hide this x equals to 22 from this point onwards within this code block. So if I write in the block inside main, I mean the block inside main function, there is this block x equals to x. So this x is, sorry, the window has hidden. So this x is actually 33. So this is writing x equals to 33 over here. Now this end scope of internal block has happened. So now we are back inside the main block. We have exited the internal block. So we have written into main x equals to x over here. So x is 22 over here, just as it was over here. but now you have declared it as a new. So I mean, this actually identifies with this code block actually, and this, since it hasn't been hidden yet, now it has been hidden, now it's now visible again. Now if I write ::x, and that means that we want to go outside the main function and see if there is any x over there and if it's actually globally visible. So we write the value x equals to 11. So if I write, now pay attention over here, so if I write integer x equals to 33, that was printing. So what if I've written ::x? So that means that it's going to access, and let me delete that because I'm going to access the x outside this. So I'm expecting x equals to 22 over here. So let's run this thing. Here, let's see. Value of x is 22, so x is available over here. Integer x equals to 33, but I've written something known as a scope resolution operator. That means I want to go outside this internal code block, and I want to access the variable which is visible outside this its domain or outside the scope. So I've resolved this : :x and x equals to 22 over here, so I can access this x over here. And in the main function, x was here, this line, I haven't changed this line, so this line means this x is actually referring to this, because this x is visible from this point onwards to here as well, because inside this code block as well as within this code block as well. And I want to go outside this, outside these curly brackets, I want to access this x which is over here, so I wrote the double colons. Last example of this scope topic, I've declared a global variable just as before, and then value of x is 11, and now I have declared another local variable essentially within this scope. So this x is actually visible over here from this point onward to all the way to here. But I have done something else. I've done this scope resolution operator. That means I'm accessing x which is actually visible outside this x. So this outside this x is actually outside this, sorry, I'm accessing x which is outside this code block, and outside this code block we are talking about this x. So had it been another x over here, we would have been talking about that as here. So that means I have accessed the x outside this block and I've assigned the value of 33. So value of x is now, and I've used the scope resolution operator, so that means x would have been, this x would have now be is 33, so that is now 33. And if I exit this code block over here and then I write value of x is, so this x is actually referring to I mean this x is actually no longer exists beyond this point, so value of x is now, so this x is actually referring to here. So as a last example, if I write value of x here, so if I did not use the scope resolution operator, that means I'm using the local x which is within this code block. So let's run this code, F11. Value of x is 11 over here, this x we are talking about here. Value of x is 22, so now we are using the local x, and value of x is 33. Now we are talking about the global x because we have changed the value of x using the scope resolution operator here. Just to clarify, as a last example, if I'm talking about just this x only, if I override this x within inside this scope, the value of x would be overwritten. I mean, I've not declared any new variable with the name x. So if I write x equals to, I mean, let's see out this thing. Let me write this code, and I'll explain it in a moment. Okay, since I'm just declaring this variable x over here, so that means that this x is actually visible from here all the way to here, as well as beyond this main code blocks as well, over here as well. Now I have not declared any new variables within these scopes, so that means that value of x is, let me run this code again. Value of x is should be 11 in the first line, and that is okay. Now if I have overwritten the value x equals to 22, that means this value is no longer 11, this is now 22, so value of x is now 22. I've written now 1 2 so that I have to so it's easy to distinguish between what the statements we are talking about. Now inside this scope x equals to 33, that means that x is now overwritten. and now the value of x is 33 over here, and in the end finally value of x is, I mean, even if I exited this scope, the last value of x would still remain. Value of x is 33 because I'm talking about the same variable x over here. So that means that the only difference which would have happened would be in the scenario in which I would have declared a new variable inside these scopes, and then that new variable within that scope would have hidden or would have blocked the scope of the variable which was declared outside. So within, I mean, if I've declared something like this, integer x equals to, now I'm talking about a new variable, and this new variable is actually here value of x is 22. So value of x is 33. That means this x is actually referring to now this x. But if I mean, if I just use some kind of scope resolution, that means I can access x outside this here as well. Okay, so I mean, where we would be using these scope concepts later on in some future lectures. We would be writing something known as for then I would have written integer I, or just a counter equals to 0, and some condition I less than, for example, 11, and I plus plus. So if I've done this code, so that means this I is only visible, or is only actually visible within these code blocks. So if I have another code for, and I just declare, I mean, this is a loop just to run a few things, so I can just declare this variable. I mean, this is essentially a new variable over here, even though it's whether maybe a different condition or something like that, and I less than 2, and then I plus plus. So that means that this I is actually a new variable, and this variable is only visible here because this I just was essentially destructed, or simply no longer exists beyond this point. Let's do some review questions, such as where does the name C++ come from? I mean, this is an increment operator. Obviously C language C language was the original language, and C++ is actually the advanced over C because it contains the object-oriented features and standard template library, which is very useful. Next question is, in each of the following assume the m has the value of 5 and n has the value of 2, and before the statement executes, tell what the values of n after each of the following statements. So m has a value of 5 and n has a value of 2. So I mean, this thing is a post increment operator, and this thing is actually an assignment operator, the compound assignment operator. So whenever you are dealing with some many operators in the same line or the same statement, you need to remember about 3 or 4 things. Number one, I mean, the rules which you need, in which the rules of mathematics also apply over here. That means the multiplication and the division and the remainder operator is always going to be happening first, and the addition subtraction are going to be happening second. Whenever you are in doubt, always use the parenthesis, just so that you are sure that which statement executes first, and after or which part of the expression actually evaluates first, and then so on and so forth. Here this thing over here, I mean, this thing is going to happen next. I mean, I can just write m equals to m multiplied by n plus plus. So this thing is going to happen next. First, the value of n is going to be multiplied with m. So m is 5 and n is 2. So that means that will be 10, m equals to 10, but and then n plus plus would happen, and then n value of n would be 3. And here this is the pre operator, the pre-decrement operator. So I can just write, let's write over here, m equals to m plus minus n. So that means that this thing happens first because it's a pre-operator. The value of n is decremented first, and value of n was 2, so now it would become 1, and m was 5, so 5 plus 1, that would equal 6. So value of m would be 6 and value of n would now be 1. So 6 and 1, 10 and 3, and just like you're done over there. Okay. And here we have the same operators. I mean, essentially we have two minus signs. So whenever we are having the same operators, usually the associativity goes from left to right. If you're not so sure about the associativity, you can just search on internet C++ built-in operator precedence, and you can have this page of Microsoft C++ built-in operator precedence associativity, and the following table shows the precedence and associativity of C++ operators from highest to lowest precedence. operators have the same number have the equal precedence unless another relationship is explicitly forced by the parenthesis. That means if you're not so sure about it, always use the brackets, because the brackets expression always happens first. So let me demonstrate that. Let's go to a code, simple code. I've written a code over here. M equals to 25, n equals to 7, and I've declared the variable result over here. So I've just written result equals to m plus n divided by 7. So obviously this division is going to happen first, and then it will be added to m over here. So n is 7, so 7 divided by 7 is 1, and the result will be an integer because all of these are integer. So 1 plus m is 25, the result would be 26. So let's run this thing. So F11, and the result is 26 as expected. Now if I want to force some expression to happen first, so I'm going to use the brackets. So I'm going to write m plus n, and that means this bracket expression, the expression enclosed within these parentheses, is going to happen first. So 25 plus 7 is 32. 32 divided by 7 is 7 into 7 for the 28, so 4 point something. The result would be 4 because the result is actually an integer. So the addition is happening first because I've enclosed that in parentheses. So if I just write F11, or if I press F11, I would get 4 because it's 4 point something, but its result is stored as an integer, so it's just picking up the whole number part. Okay, so whenever you are in doubt, always use the parentheses. But let's see another example. Let's minimize that. Yeah, minimize that as well, and just see m minus 8 minus n. So if you can go from built-in operator precedence, so if you can just search really quickly where that subtraction, look, multiplication division model always happens first because it has a higher precedence, and addition subtraction happens later if they are in the same line. If you are in doubt, always use the parentheses. So I mean the precedence goes from left to right. So I mean, sorry, the precedence, the left to right associativity goes from left to right. The precedence group is 5. Okay, so it goes from left to right. So m minus 8, 25 minus 8 is 17. 17 minus 7 is 10. So the result would be here, I mean the result would be this expression would be 10. M equals to n equals to 3. So equality operator, not sorry, equal to sign, the assignment operator, not equality. Equality is actually for checking whether something is equal to another. So let's search quickly for equal to assignment operator. It has the right to left associativity, so that means it goes from right to left. So 3 is assigned to n is 3, and m is also now 3. M percentage n, and percentage n means that we are talking about the remainder operator. So remainder, I mean this thing would be, I mean n and n both would be, I mean let's write 3 both. Okay, so m percentage n, and both are integers. Percentage operator always happens also 25. 25 percentage 7, I mean modulus operator. So 25 and 7, 7 3 the 21. So the remainder would be 4. The answer would be 4 over here. Now this thing I'm going to demonstrate that. Let's write over here m percentage n plus plus. The value of n is going to be used first, okay, and then the value of n would be incremented. So m percentage n, I mean we have the 25 divided by 7, and the remainder would be 4. So the expression is the result of this expression is 4, and the value of n after running this expression would be 8 because it was 7. Now it has become 8. Even if you use a bracket, you will still get the even if you want that it has to be incremented first, you have to use this thing. Let me demonstrate that. Let me write this expression. If I can move this over here, so I'm going to write an expression over here. So let's delete this thing. I'm going to write m modulus operator n plus plus. So let's run this thing, and it says the result is 4 because 25 percentage 7 is 4, and the value of n, if you want to just write the value of m and n are m let me put it in here, and n. Okay, after running this code, okay, let's put some space over here. Result is 4. sorry, result is 4. The value of m and n are 25 and 8. M, we did not change the value of m, I mean we incremented n, so that the value of n is actually used first and then it was incremented. Now like if I use these parentheses, right, the round brackets, so that I want to make sure that it happens first, but look, I mean this has some special behavior that if we are talking about the post increment or the pre-increment or the post decrement or the pre-decrement, the value of n is still used first. Even if you have used like 2 or 3 brackets, it would have still used the value of n first and then it would have incremented. So the result would still be 4 because 25 remainder 7 is 25 divided by 7, the remainder is 4, so no change about that, and it has incremented the value of n after that, even if you have used the brackets. So keep in mind that pre and post increments have a special meaning. Even if you have used the bracket, that would have used the value first and then it would have changed the value. M percentage plus plus n obviously is going to, if I just write plus plus n, so that would have incremented the value of n 8 and then it would have used it. So 25 divided by 8 is 8 to the 24, so the remainder is 1. So I expecting the remainder of 1 over here, and the value of n and n are 25 and 8 as before, because after running the statement the value of n is now incremented. After before running the statement, I mean before the running of the value of n was incremented first and then it was used. Had I used n plus plus, then it would have run the statement first and then it would have incremented the value. So sorry about that. Okay, so this problem, m plus plus n minus n minus minus. So plus plus m, that means the value of m would be 26 minus n, value of n is 7, so that means that 26 minus 7 would be 19, and then after running this statement the value of n would have been 6. So let's run this statement first. Let me copy that. So plus plus m minus n minus minus, so the value of m would have been incremented first, so that means the value of m was 25, it would have been incremented first, so because it's a pre-increment, so 26 minus n, the value of original value of n would have been used, so the original value of n was 7, so 26 minus 7 is 19, and that's what we are seeing over here. And now the value of m, since it was incremented, so 25 to 26, and the value of n after running this statement has now been decremented, so we are seeing the value of n as 6. And here are the solutions. So watch out, I mean here within these brackets, the bracket I mean this is a special operator, this thing is going to be used first and then it would have been incremented. I mean it would have been incremented first and then it would have been used, and here incremented first and used and decremented later, but I mean 7 is used first and decremented later. So the example, I mean the result which we have seen so far. If you want to see much more operator precedence, you can see this web page. This is a really useful web page, but as far as the increment and decrement operators are concerned, they have this special even if you are using the parentheses, they have a special behavior depending on where you have put the increment or decrement. Had it been pre-increment, the value is changed first and then used. Had it been post operator, the value would have been used first and then changed. And after that, I mean essentially many of them are left to right associative. Whenever you are in doubt, always use the parentheses, except for the increment or decrement operators. They work as I've demonstrated over here. Okay, so coming back to the slideshow. Okay, how do the following two statements differ? Character ch equals to a, I mean they have essentially the same meaning, because we know that the ASCII code of a is 65, because inside behind the scene this character is actually an integer. So that means that both the statements have the same effect. They declare ch to be a character initializer with the value 65. Since this is the ASCII code for a, the character constant can also be used to initialize ch to 65. I mean if I've just printed ch as an integer, that would have displayed 65. If I've used just 65 to be displayed as character, that would have displayed a. I mean essentially the same thing. Without the double quotes, you can just use the ASCII code to initialize a character to appropriate value. I mean keeping in mind that it's understood that you actually know ASCII table or you have ASCII table in front of you. Okay, next, what code would you use to find the character whose ASCII code is 10? Simple, just write character and use the, I mean, it's not actually typecasting because I've explained that in some kind of a forum. Not so sure whether that was section A or B, but if you, I mean, there's a slight difference in this code. I mean, let's had I written, let me come over here. Had I written char in brackets and then whatever I've written 100, this is actually typecasting. I mean, 100 is typecasted to character. If I write character and then I write 100, that means that I have called a constructor of character object. I mean, going to explain that after midterm. I'm making a character object and I'm initializing it with the value of 100. So that means that 100 is an integer. It would have been taken as character, and 100 is, I'm not so sure what the ASCII code 100 represents, what character. Not, I mean, maybe some small characters from A, B, C, D. I mean, so you can just find out within ASCII table. Okay, I mean, essentially both the effects of both of these things are essentially typecasting. But here, I mean, slight difference is that this is actually typecasting and this is actually constructing a character object with a value, initial value of 100. But essentially the result would be same over here. What does the floating point mean? Why is it called that? Because we have a variable precision. Floating point is used to describe the way decimal numbers or rational numbers are stored in a computer. The name refers to the way a rational number like this can be represented in the form of this by letting the decimal point 10 to the power 5, then to the decimal point float to the left 5 places. Obviously, it's in binary format. It's just used to explain the decimal numbers. I mean, behind the scenes computer is in binary. Okay, next problem. What is numeric overflow? I mean, obviously, size of numeric variable when gets too big for its type. For example, on most computers, short cannot exceed 32767. So, I mean, I'm signed short. So that means if a variable, I mean, if you store a larger variable, obviously it's going to cycle around to go to the negative value and so on and so forth. That would be an overflow. How does integer overflow differ from floating point overflow? There's a slight difference. Integer overflow occurs when the value of the offending variable will wrap around to negative value if it's a signed number, or had it been an unsigned number, that will go to 0, back to 0 and go all there. I mean, I've demonstrated that in a previous lecture. It produces erroneous results. When the floating point overflow occurs, the value of the offending variable will be set to the constant INF representing infinity. So obviously that will be not a number errors later on. What is a runtime error? Obviously, when, I mean, it's not a compile time error, there is no syntax error. You have written the code correctly with no syntax error, but there might be some runtime errors such as numeric overflow or maybe a division by 0. I mean, these are runtime errors. I mean, obviously, if you're expecting input from the user and that user, or even if within the code itself, I mean, has no syntax errors there, the program will run, but it will produce an erroneous results. Those are runtime errors because they are produced at the runtime. What is a compile time error? Give examples of 2 different types of compile where you have a syntax error essentially. When program is being compiled, for example, syntax errors such as omitting a required semicolon, using an undeclared variable as we are demonstrated in this lecture, using a keyword for the name of a variable. That's important. You cannot use a keyword, reserved keyword, as the name of a variable. What is the difference between a reserved word and a standard identifier? In the previous lecture, I think in the live lecture 2, I've explained the difference between the keywords and the identifier. There is also something known as a reserved words and standard identifiers. Reserved word is a keyword in a programming language that serves to mark the structure of a statement. For example, keywords if, else are reserved words. Obviously, you cannot use them. A standard identifier is a keyword that defines a type, such as character, integer, float are some of the standard identifiers. And there are 63 or so keywords in C++. I'm referring to C++ 98 over here, such as if, else, whiles are some of the reserved words. You cannot use them as name of the variables because, I mean, that will throw up the error. So reserved words can also be not used as a name of a variable. What is wrong with this code? Fall, spring, summer, season, spring. I mean, you cannot have same character constants over here. I mean, you need to rename this thing. So the second enum definition attempts to redefine the constants spring, summer, and fall. Obviously, summer and fall, they are all same over here. So just rename this spring 1, summer 1, fall 1, or some other name which might be different, or just change the case if you want to. But usually the standard is you use these capital letters to define the correct integer constants. What is wrong with this code? Jerry, Henry, and WD. I mean, this thing, these are the standard identifiers. Okay, I'm sorry, not standard, I mean these are the valid identifiers. Is valid identifiers, I mean you could start them with a underscore, they could contain a letter, they could contain a number, no problem at all, but you cannot have identifier of some constants as strings. I mean these are essentially strings, so enumerators must be valid identifiers. String literals like Jerry, Henry are not identifiers. You cannot name, I mean you cannot have a string as a name of some character constant. In the end, the summary of this lecture is we did the scope of the variable topic, and that means where variables are actually visible. We did the nested and parallel scopes as well, and we discussed it extensively. Also, we did some review problems or review questions about the topics in which we did in the previous lectures, such as operator precedence topic, as well as in which you have to keep in mind, if you're wherever you are in doubt, always use the parentheses, except for the increment and decrement operators. They just work as they are supposed to, even with the use of the parentheses.